This is the rest of section 2.5. We are now proving statements about angles. So all of the properties of equality and properties of congruence that we've already talked about are still in play. So remember, properties of equality means they all need to be used with an equal sign. Properties of congruence means it's used with a congruent sign. These three were listed under both. So reflexive, symmetric, and transitive can be done with either an equal sign or a congruent sign. But we have some more definitions that we're going to use. And all of these, if you notice in the middle, there's a double arrow. So that means the order of it could go either way. We could start with this way and then turn into the second, or start with the second and turn into the first. So the definition of congruence is still changing the symbol. So instead of saying measure of angle A equals measure of angle B, we would say that angle A is congruent to angle B. The definition of bisector, so if angle RST is bisected by ray SU, so if we looked at what that would look like, RST with the U in the middle, then angle RSU would be congruent to angle UST. The definition of complementary, when we know that two angles are complementary, we could say that their sum is equal to 90. So the measure of angle 1 plus the measure of angle 2 equals 90. And then the definition of supplementary would then be that they add to 180. The definition of perpendicular, it's often the one that's hardest to see because usually when we're using definition of something, it's a word and not a symbol. But we see that up here in the first one, it's possible to use definition of the symbol. So definition of perpendicular means that the angles form right angles. So if I knew that SR was perpendicular to ST, then I have made angle RST, which is a right angle. I abbreviate right to RT. So the definition of perpendicular, if I know that two lines are perpendicular, then I can say that the angle formed is a right angle. So this is different than the definition of a right angle, which is that an angle is equal to 90 degrees. So saying that angle 1 is a right angle would mean that the measure of angle 1 is equal to 90. This is different than complementary. Complementary is when we're talking about two angles that add to 90. Right angles when we talk about a single angle being equal to 90. And we also have the angle addition postulate, like we had the segment addition postulate. So remember that's saying that the two smaller pieces of angle add up to the whole thing. So that would be the measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. Right? The whole thing was ABC, and then the two smaller ones were ABD and DBC. So much like the segment addition postulate, this is going to kind of come out of nowhere. It's not going to be based on any previous statement that we make, and it's used to introduce different angles into the problem that we haven't seen before. So for our first example, let's just name the property that the statement illustrates. So if BD is in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So we're adding up two smaller angles to say it equals the whole thing. That's the angle addition postulate. I'm going from saying measure of angle 1 equals 90 to saying that that is a right angle. So being 90 degrees is what it means to be a right angle. So we would call that the definition of a right angle. And then in our third one, if the measure of angle R is equal to the measure of angle S, then angle R is congruent to angle S. So we're switching it from an equal sign to a congruence. Definition of congruence. So here's a check-in for you to do. Pause if you'd like. The answers are posted online. So our next problem is an actual proof. So remember our steps. We know given usually goes first, so I can put measure of angle 1 equals measure of angle 3 is given. And I know the proof statement is going to go last. So the measure of angle DBA is equal to the measure of angle EBC. So step 2 says the measure of angle 3 plus the measure of angle 2 equals the measure of angle DBA. So here is DBA. And DBA is in fact made up of those two smaller angles, angle 3 and angle 2. So this is the angle addition postulate. And now we're going to use substitution. So if they're telling me to use substitution, I had an equation here, and 3 was the same thing as 1. So instead of writing 3, I can write 1. And now we want to do another angle addition postulate. So the only other bigger angle I could really use in this picture would be this bigger angle, the one that's made up of 1 and 2. So I can say that the measure of angle 1 plus the measure of angle 2 equals, and this is angle EBC. So my very last step, I have DBA, which I've seen here. I have EBC, which I've seen here. And when I look at those two steps combined, we can see that we can link them together. So this would be the transitive property. Another example for us to do together. They don't have a picture for us. I'm actually going to start by drawing that. So we know we have an angle LMN, and we know that ray MP bisects it. So there's our picture. So we are given that ray MP bisects angle LMN, and we know the last step is going to be 2 times the measure of angle LMP equals the measure of angle LMN. So step 1 was bisects. Now I see I have 2 congruent segments. I saw a word. I'm going to use the definition of that word. Definition of bisects. And now I have the same letters in step 3 and 2, but instead of using congruence, I'm using equals. So that's the definition of congruence. And now we want to use the angle addition postulate. So the angle addition postulate we know is made up of the 2 smaller angles equals the whole thing. All right, I'm going to make my writing a little smaller just so we can hopefully fit it all. So the measure of angle LMP was one of them, plus the measure of angle NMP was equal to the whole thing, the measure of angle LMN. Okay, so the next line looks similar to step 4. We have an LMP still in the first spot. We have the measure of angle LMN in the last spot, but the middle spot changed. Instead of the measure of angle NMP, we have the measure of angle LMP, and those were the same thing. So we have used substitution. And now my very last step, I took the 2 different measure of angle LMPs and I combined them. Anytime we combine like terms, we call that simplify. Another example for us to do together. We're given that the measure of angle ADC is equal to the measure angle BDE. And we know the last step is supposed to be the measure of angle ADE equals the measure of angle CDB. So step 2 did not come from step 1 because I didn't add something to both sides. So if I look at my picture, BDE is this angle here, plus ADB is this angle here, is adding up to ADE. So we're saying these 2 smaller angles add up to this whole one. That is the angle addition postulate. Then I have everything is the same in the equation in step 3 as step 2, except the very first spot. Angle BDE turned into angle ADC. So when we turn one thing into another, we are using substitution. Now I have a whole different equation equal to CDB, which I've never seen before. So CDB is the angle they're talking about, is made up of ADC, which is this angle in this corner, and ADB, this angle in this corner. So again, we're saying these 2 small pieces of angle add up to the whole bigger thing. That is another angle addition postulate. And for my last step, I have ADE equals CDB. So ADE was last here, and CDB was last here, and both of those lines were equal to the exact same thing. So we can link them together using the transitive property. I believe we have one more together problem, and then you could try one on your own. So we are given in step 1, and I see another given in step 6. So the other thing we have not mentioned yet is that the angle ABD is congruent to angle DBE. And my last step, I know, should be that angle ABD and angle EBC are complementary. So those are all the things I could fill in without really knowing anything else. So remember what we said, what it means to be perpendicular. So if I say I have perpendicular lines, I know I would have been able to put a right angle symbol there because they're perpendicular, which means the definition of perpendicular is saying that we have a right angle. So angle DBC is a right angle is using the definition of perpendicular. Now, knowing it's a right angle and saying that it equals 90 degrees is using the definition of a right angle. So here we saw the word right angle, next step we use definition. Here we saw the symbol perpendicular, next step use the definition. Step 4, I'm now introducing some information. I've never seen angle DBE or EBC before. So we're saying angle DBE plus angle EBC is equal to the whole thing angle DBC. So that is the angle addition postulate. And now I have DBE plus EBC is 90. So I've seen stuff that looks like this before. I saw DBE plus EBC here, and I saw 90 here. If I look at those two statements, they were both equal to the same thing. So this is another linking problem using transitive. Then we were given that those are congruent. We're changing the symbols using definition of congruence. So that means I'm going to turn this into measure of angle ABD equals measure of angle DBE. Step 8 says the measure of angle ABD plus the measure of angle EBC is 90. I saw that in step 5, but instead of writing DBE, I've written ABD, so I've replaced it with something that it's equal to. So doing that is using the substitution property. Almost said the wrong thing. And then my last step is calling those two angles complementary. We're calling them complementary because they added to 90. That is the definition of complementary. So there's one more problem. If you'd like to try it, you can pause. But this is the end of lesson 2.5, angle proofs.